structure of the particular problem or that linear programming problem. So first of all, we will have to see the steps which are there to formulate the linear programming problem, because as we all know that first of all there is going to be a simple data is going to be there, which is taken from the past experience or the past records, and the data is to be converted into the mathematical format, that is called as a formulation of the linear programming problem. And then the solution for that particular mathematical problem is to be taken out from different types of methods. So here we are going to deal with the graphical method to get the solution for that particular mathematical model. So before going to the solution, we need to actually understand what are going to be that steps whereby we are going to formulate the linear programming problem for graphical method. So whenever we are having the information or the data to formulate the linear programming problem, so first of all, by reading the problem, we will have to decide what is the aim or what is the solution required from the particular problem, because based on that we are going to define the decision variables. So these decision variables are going to actually define the particular solution for that particular. Now, in these decisions variables can be more than two also. So basically, there are generally two decision variables are there, and it may be more than that also. So that the decision variables are going to give the solution for the linear programming problem. So by using these decision variables, we are going to construct the objective function. Objective function in the sense what is going to be the objective of that particular problem, or what is the requirement from the particular problem, or what should be the solution for the particular problem, and that is going to be the this objective function for the particular linear programming problem. So this construction of objective function is done by using this decision variables. So decision variables are going to play a role while constructing an objective function. So this objective function is going to give the solution for the particular problem. Now the third step that is going to be there is the formulation of the constraint equations. Now if you see in this particular word constraint in the sense the limitations. Now already we have constructed the objective function. Now objective function is obviously going to give the solution, but that objective function or that objective cannot be achieved without any limitations, because whenever we want to achieve something there are going to be the limitations. The limitations may be the environmental conditions, maybe the limitation because of the financial constraints, maybe the limitations because of the labor constraints, maybe limitations because of the time constraint. So these such type of constraints are going to be there, which are going to limit the objective function. So just by knowing the objective function, just by knowing the decisions variables, we cannot go for the solution. So next thing we require to know is the constraints. So these constraints are going to be there after the objective function. And the fourth one is the non-negative constraints. So what is the meaning of the non-negative constraint and why these are required? So we'll understand this once we will go to the problem. Now the first and basic limitation of the graphical method is that because we know that apart from the graphical method there are another methods also, and by these methods also we can solve the linear programming problem, but still we are preferring here and graphical method. So reason behind using this particular graphical method is that it is giving the solution in the shortest possible time. So this graphical method is going to give the solution in a shortest possible time, but the limitation is that this graphical method can be only used when there are going to be the only two decision variables. So this is going to be the basic limitation of this, that these are only applicable, or the method of graphical solution is only applicable when there are going to be the two decision variables. And so that there are another methods, because it is not possible that whatever the data we are going to have, that data is always required to be converted into the two decision variables, because sometimes, or the most of the times, there are going to be the decision variables more than two also. So that time we may not be able to apply this particular graphical method, and that time we may need to go for the simplex method or two-phase method or the big M method. So we are going to solve, as we are going to study about only graphical methods, so we are going to solve the problems having only two decision variables. Now let's see what are going to be the steps to solve the linear programming problem by graphical method. Now the first step which is required to solve the graphical method or the problem by using the graphical method is that already we have formulated the particular linear programming problem. In that problem we are having objective function, then we are having the constraints, and then we are having, first is the objective function, second is the constraints, and another one is a non-negative restrictions. So the first thing that we are having is the objective function. But though we are having the objective function, the first thing while solving the problem is we are going to know about the constraint first. So while solving the problem we are going to see the constraint first, then we are going to see, or we are going to convert that each inequality to equation by equating with the zero. Now when we are having the constraint, these are actually the inequalities, and we know that whenever we are solving any problem, or whenever we want the values of the variables, we cannot get that values when we are having the inequalities, because we can solve the problem when we are having the equation. So here what the important thing is required is that it should be an equation, and to convert that particular inequality into equation we need to equate it with the zero. Okay, so the first step we have got is the consideration of the constraint first. Once we will get the constraint, so one by one we will convert that inequality or the constraint, each constraint, into equation by equating with zero. So we have to equate with a zero, and we have to convert it into the equation form. The third step that we are going to do is to calculate the coordinates for that equations. Now we have converted the constraints or inequalities into the equation, and then we have gone for calculation of the coordinates. So then we are going to calculate the coordinates for that particular equation. So one by one we are going to take that inequality, one by one we are going to convert it into equation, then by comparing with the zero, and then for that particular equation we are going to calculate coordinates for that particular equations. Coordinates are nothing but the values of that particular variables. Whenever we are going to equate that particular equation with the zero, immediately we'll get the values for that particular coordinates. Now the fourth step is going to be, once we will get the coordinates for all the inequalities, keep it in mind we are going to get the coordinates only for constraints and not for the objective functions. So step 4 is that calculation, or sorry, step 4 is that we will have to plot all that coordinates what we have got from the step 3. That coordinates we are going to plot on a graph. So as we know that we are having only two variables, so for each equation we may have either one variable or maximum two variables. So we are going to have only minimum one coordinates and maximum two coordinates. So by using that coordinates we are going to plot each equation, because for each equation we are going to have the coordinates on a graph as a straight line. So for each equation we are going to have a coordinates. So now if suppose there are going to be two coordinates for that particular equations, so just we will have to plot that two coordinates, for example coordinate of x, coordinate of y, and that we will have to connect that points and we will get a straight line. So for each equation we are going to get one straight line. Step number 5 is to show the region for each line as per the inequality sign. So now here is going to be actually one more thing, because we may have the sign of less than type, we may have the sign of greater than type, or we may have a sign of equality also. So these three types of sign we are going to have, and based on that three types of sign, so we are going to consider the region for that particular line. So by using this constraint, actually this constraint are giving the limitation on the solution, and by using these constraints we are going to get the particular region. Now the step 6 is that highlight the common region to all constraints, that is it will be feasible region. Now this is going to be the next step, that is to get the feasible region. And what is the feasible region? Feasible region is common region to all the constraint. Now in step number 4 we have seen that we have plotted each equation on a straight line, as a straight line on a graph, and we have got the region for each the line as per the inequality sign, and respectively as per that particular inequality sign we will get the different types of region. But by considering all the constraint, we are going to get one common region which will satisfy all the constraint, and that common region is called as a feasible region. So feasible region is nothing but, because the feasible region we are getting which is common for all the constraints, so obviously whatever the points we are going to consider in that particular feasible region is going to satisfy all the constraints. So any point in the feasible region is going to satisfy all the constraints including non-negativity restrictions. So that particular point within a feasible region will satisfy all the constraints at a time. So these points are going to be there within a feasible region. Next step is going to be point out all the corner points of feasible region and note coordinates, and then coordinates will give the required feasible solution. So next is a point out all corner points of feasible region. This thing we will have to keep it in mind. Only we will have to point out corner points of the particular feasible region. So we are going to only focus on the corner points. Anytime this question is also asked, so which points we are going to consider from the feasible region to get the solution for that particular linear programming problem. So in that case we are going to consider only corner points of that particular feasible region. So coordinate points may be different, because some feasible region will have three coordinates points, and will have four coordinate points likewise, or sometimes it will happen that there is no any feasible region. So that cases we are going to study. So there we are going to consider corner points only. We will note down that corner points, and we will put note down coordinates for that particular corner point. So we will note down coordinates for each corner point separately from that particular feasible solution, and whatever the coordinates we will get from that particular uh, corner points, that coordinates individually we are going to put it in a objective function. So for each corner point we are going to get the two coordinates, and obviously in our objective function also there are going to be the two variables. So that coordinates are kept in an objective function for the each and individual point, and for that particular point with respect to that point and that coordinates we are going to get the value for this objective function. So if there are going to be the four corner points, we are going to get four different values for the objective function. It may be a 0, it may be a more than that. So, and from that particular solution, because multiple solutions we are going to get, so as many coordinates, that many solutions or answers are going to be there for this particular objective function. But based on the nature of objective function, so whether objective function is of maximization type or it may be a minimization type, and already we have discussed that whenever we are considering about the profit, then we are having the objective function as maximization. Whenever we are considering about the problem of investment, about the problem of cost, that time we are having the uh, objective function as minimization. So if minimization will be there, we will select minimum value from this obtained values. If your objective function is maximization type, we will select maximum value from our obtained solution. So these are the common steps which are required to solve the any type of graphical problem. Now we'll solve problems by using these particular steps. Let's take the first problem. Now the first problem is like this. Newly set up a small scale ice cream company is planning to launch two types of ice creams in the market, that is chocolate and mango flavored. So it means that a newly set up small scale ice cream company is there, and that ice cream company wants to launch two different types of ice creams, that is two different types of ice creams with two different flavors, that is chocolate flavor and mango flavor. Now as per the market survey, local market can have maximum demand of 6 boxes of chocolate ice cream and one box of, right, and it says that one box of chocolate ice cream requires 2 hours of production, while mango flavor takes 4 hours for one box production. So once again we'll see this. As per market survey, local market can have maximum demand of 6 boxes of chocolate ice cream. So market says that only it can accommodate only 6 boxes of chocolate ice cream. One more condition is given, that one box of chocolate ice cream requires 2 hours for production. Means in a 2 hours, one box of chocolate ice cream is prepared or produced. While to produce a mango flavored ice cream, so one box requires 4 hours. So chocolate ice cream requires 2 hours for one box, and for mango flavor ice cream, 4 hours are required. So obviously double as compared to the chocolate ice cream. Daily working hours of company are 20. So daily the company is working, or the labors are available for 20 hours. While company can produce 9 boxes totally per day. So company can produce 9 boxes totally per day. So it is said that totally, it means by considering mango flavored ice cream as well as chocolate flavored ice cream. So both the type of ice cream, or by considering both type of ice cream, there are total 9 boxes which can be produced daily. So it means that by working for 20 hours, company is able to produce 9 boxes, which includes chocolate ice cream as well as mango ice cream. Next is that profit per box is rupees 10 and rupees 8 for chocolate and mango flavored ice cream boxes respectively. It means that not a one ice cream, it is saying per box, means one box of chocolate ice cream will give rupees 10 profit to the company, and one box of mango flavored ice cream is going to give rupees 8 for the company. Now the obviously a question is simple, that how much production of each ice cream boxes should be done to maximize the profit. So the company is having a simple question, is that how much should be the production of chocolate flavored ice cream and mango flavored ice cream. So there are going to be different condition. A company can go for only chocolate flavored ice cream if profit is more. A company can go for only mango flavored ice cream if profit is more. Or there may be the combination of production of chocolate flavored ice cream and mango flavored ice cream. But provided that it should give a maximum profit. So whatever the condition may be, it should give maximum profit. Okay, so let's see solution. First of all, we will have to understand what is the objective of the particular problem. So mostly objective is specifically given in the problem. This is the data that we are having. Now looking at the data, we will get a clear picture of the objective, that company wants to maximize the profit by production of chocolate and mango flavored ice cream. So simple objective function is that maximization of profit. And how the company is going to maximize the profit? By production of ice cream boxes with chocolate flavor and mango flavor, two different types of ice creams and two different types of boxes. So the question that company is facing, that how many boxes of chocolate flavored ice cream and how many boxes of mango flavored ice cream, because as many number of boxes we are going to multiply it with that much profit. and simply we will get the exact profit. So objective function is to maximize the profit. How? By going or by selling the chocolate flavored ice cream and mango flavored ice cream. So the question is simple: what should be the number of boxes for chocolate ice cream, number of boxes for mango ice cream? So our first consideration will be there are going to be x number of boxes, there are going to be x number of boxes for chocolate ice cream, and there are going to be y number of boxes for mango flavored ice cream. So simple consideration we have made, that x number of boxes of chocolate ice cream and y number of boxes of mango ice cream. So immediately we'll get the objective function. So our decision variables are two different decision variables. The first one is x, second one is y. X represent number of boxes of chocolate ice cream, y represent number of boxes of mango ice cream. Now this objective function, simply it has been given that we will have to maximize the profit. So I have taken maximize z. You can replace the z also, that will not be a question. So maximize z. Now a single box of chocolate ice cream is giving profit of rupees 10. So there are x number of boxes, so total profit is going to be 10x. Similarly, a single box when it is sold, it is going to give the profit of rupees 8, that is a mango flavored ice cream. Such we are having the boxes, y number of boxes. So one box profit rupees 8, y box profit will be 8y, and the total profit is going to be 10x plus 8y, 10x for chocolate flavored ice cream, 8y for mango flavored ice cream. So this is going to be the objective function for the particular problem. This is what the first step was. Second step is going to be the to decide the constants, because see, as many number of boxes company will produce, that is going to be the profit. But it is not as simple as like that, because there are going to be some restriction, and restrictions are simply given here, that market can accommodate only 6 boxes of chocolate ice cream. Then again, one box of chocolate ice cream requires 2 hours of production. For mango box, it requires 4 hours of production. So that is going to be the limitation for the particular boxes. Now let's go for constant equation. Okay. Now one by one we'll see the constants. Now the first thing is given in the problem is that local market can have maximum demand of 6 boxes of chocolate ice cream. That means maximum number of boxes that can be sold in a market for chocolate is 6, means 6 boxes of chocolate ice cream can be sold, and we have considered how much x boxes of chocolate ice cream. So it means the number x, the value of x can be maximum 6 or less than that. So it will give clear picture that value of x should be either equal to 6 or less than 6. So we will get the first constant. That means x is going to be either equal to 6 or less than 6, because market can accommodate only 6 number of boxes. So this is what the first constant equation. It is very simple to get. Now the second constant, as the problem we will read sentence by sentence, accordingly we will get the constants. Second sentence is that one box of chocolate ice cream requires 2 hours for production, and mango box requires 4 hours of production. Now how many boxes of chocolate we have considered? X number of boxes. One box require how much time? 2 hours. So total time required will be 2x. And second is mango flavored box requires 4 hours for one box. How many boxes we have considered? Y number of boxes. So total time will be 4y. But company daily working only for 20 hours. So 2 hours for one box of x, total box number of boxes are x, 2x plus 4y. It cannot be more than 20 hours, because total time cannot be more than 20 hours. That is the working time of daily. So the next equation, next constant will come out as 2x plus 4y, 2x, that is the time required, total time required for chocolate flavored ice cream box production, 4y, that is the total time required to produce ice cream boxes with mango flavor. This total time should not be more than 20. It either equal to 20 or it will be less than 20. So we'll get the symbol here. Now two constants we have got. What is the third line? While company can produce 9 boxes totally per day. That means total production capacity of the company is 9 boxes. Totally it means by considering chocolate as well as by considering mango. So number of chocolate boxes are X, number of mango boxes are Y, and total number of boxes can be maximum 9 or less than that. So third constant we will get as X plus Y. That means total number of boxes can be either equal to 9 or it can be less than 9. But it cannot be more than 9 because that is going to be the total production capacity of the company. So this is what three constraints we have got. And one more third step we will have to go is a non-negativity constraint, because see, we have considered the X number of boxes and the number of boxes can be 0. Maybe we will not go for the production of chocolate ice cream, maybe we will not go for the production of mango based ice cream, but it can be 0 but it cannot be negative. That means X must be either 0 or more than that, Y must be either 0 or more than that, so that that constant also will have to consider. That is called as a non-negativity constant, and it should be X and Y must be either equal to 0 or it must be greater than that. So this entire structure is called as a formulation of linear programming problem, starting from considering objective function, then getting constraints. These three are constraints, and then non-negativity constraint. That is going to be the last part of formulation of. Okay, so now we have come up to the third step, that is formulation of the mathematical model. We have seen the formulation of the objective function by using the decision variables. We have seen to consider the constraint that is going to give the limitation on this objective function, and last one is a non-negativity constraint. Now let's see how to solve this particular problem. Now the next step we have seen was to convert this constraint, because if we were to solve this particular problem, we will have to convert these constraints, because here is less than, less than, less than, that we will have to convert into equality. Okay, so the first constraints we are having, because already we have seen that the only we are going to consider first constraints. So first constraint we are having is that X is less than or equal to 6. Now, to procedure to convert the inequality into equality is that just to compare it with the 0, or make it equal equation and compare to the 0. So once we will make it the equation, this first will become X is equal to 6, because simply it is a single variable constant. So it is a simple, so it will simply become X equal to 6. There is no question of the Y. Now the second constraint is a 2x plus 4y less than equal to 20. 2x plus 4y less than equal to 20. Now how we are going to convert this? Simple, 2x plus 4y equal to 20. 2x plus 4y equal to 20. Then when we will put x equal to 0, when we will put x equal to 0, that time immediately, so first when we put the x equal to 0, so this 2x will become 0 and 20 by 4 will become y equal to 5. Same step we have to repeat for another variable. Now I will keep y equal to 0 and I will get x as 10. So we have got the two variables, this y equal to 5 and this x equal to 10. Similarly, for third constant we are having x plus y equal to 9. First of all, we will convert into equality, x plus y equal to 9. Then once we will put x equal to 0, we will get the value of y. Then we will put y equal to 0, we will get the value of x. Okay, so when we will put x equal to 0, we will get y equal to 9. When we will put y equal to 0, we will get the x equal to 9. So a simple step to calculate all these things is that just to put once x equal to 0, then y equal to 0, and then easily we will get the values of x and y. So we have got the values of x and y. Now we will have to plot these coordinates on the graph. So So finally we have got all the three coordinates for all the three constants. A simple method is that just convert inequality sign into equality by putting, and then put one variable equal to 0, you will get another value. Put the second variable equal to 0, you will get the first one value. So by this way you are going to get the all the variables for all the constants. Now we will have to plot this all the constants on graph. So once we will get the coordinate, we will start to plot the graph. Now let's start plot the graph by using this particular coordinate. So we are having the two variables, and that two variables will plot on two different lines. Now first we'll have a x-axis, then we will have the y-axis. Now looking to the values of x and y, because minimum value of x is 6 and maximum value of x is 10. Minimum value of y is 9, maximum value of y is 5. So maximum up to 10, we are required only that much of coordinates on the axis. So accordingly you can distribute the coordinates. So 1 2 3 4 5 6 7 8 9 10. Similarly at the y-axis also we will have the coordinates, right? So the judgment of this coordinates is going to be taken from these values of the particular coordinates. So just you will have to see the maximum value of the coordinates, and that can be there on the axis. Now let's see one by one how we have to draw the particular lines on the graph. Okay, so the first equation is x equal to 6, so it is going to be the, now okay, before that we are having the constant as x comma y must be either greater than or equal to 0. That means all our coordinates or all the lines are going to be in a first quadrant only. Okay, so these symbols will show that we are going to plot all the graphs in a first quadrant. Okay, so let's take the first equation, that is x equal to 6. So this line is going to be exactly vertical line. So it is going to be the vertical line, because x equal to 6, that means parallel to y, and at this juncture of 6 this line is going to be there. This line is for x less than equal to 6. Now as x is less than 6, that means all the values of x must be less than 6. Less than 6 means inside this particular line, because if I will take any point in this region, it will reflect the value of x more than 6. So I need either value on this line or just less than this. So the region will be this way. This arrow is showing that we are considering this region. Now let's go for the second line. So this is going to be the second line based on the equation 2x plus 4y equal to 20. So x0 y5 y0 x10. So value of x is 10. So here is the 10, value of y is 5. Just plot these 2 points and connect these 2 points using this straight line. So this I have connected by using this straight line. X is equal to 0, y equal to 5. This is for equation 2x plus 4y less than equal to 20. Again here the value of 2x plus 4y is going to be less than 20. That means below the line. If it is a greater than 20, we have been considered the region above the line, but it is now less than 20, so we will consider, or this arrow is showing the region below the line. This arrow is showing the region below the line. This is the second constraint. The third constraint is x plus y equal to 9. X is 9, y is 9. So here x is 9, y is 9. We have plotted these 2 points and connected with the straight line. So the equation is x plus y less than equal to 9. Obviously it is again less than, so region will be below the line. Region is going to be below the line. Now if you will observe that all the regions are below the lines, so we are going to easily trace a common region to all the lines, because if we will consider this vertical line, this is going to be the region shown by these lines. So common region is going to be only these regions starting from 0 to 6 to this crossing point along this line and up to the 5, and it will close here. So this is going to be the closed loop for that particular line. So see here we have got this region as a this particular common region, and we know that this common region is called as feasible region. So whatever the region that has been shown with yellow color, this is going to be the common region. Once again, you can review these arrows. This is showing this way, this is showing this way, this is showing this way, and this is showing to the downside. So totally we are going to get this is going to be the common region. So now if you take any of the point in this yellow region, it will satisfy all the limitations by all these lines. Now suppose if I will take the point here, it will not satisfy the limitation by this line or by this line. If I will take point here, it will not satisfy the limitation by this line. Okay, so these are going to be this is going to be the common region, which is called as a feasible region. Okay, so our objective function is maximize z equal to 10x plus 8y. Okay, so now next step that we have to calculate the corner points and then the value of z. Okay, so one by one we will see the corner points. Where are the corner points? How many corner points are there? This one, that is nominated as a. Then the coordinates for that particular point a are 0 comma 0. Here is the point. Second is the point B. You can easily observe that here x equal to 6 and y equal to 0. So coordinates for B will be 6 comma 0. Next point is here at the crossing of the line, this second and the first line. So C point, the coordinates are obviously x equal to 6 is clear here and y equal to 2. So once you will plot this graph on a graph paper, you will easily get the coordinates. Otherwise, one more method is that, so we'll get the coordinates for the point C as 6 comma 2. So I have already told that one more method to calculate coordinate is whatever the crossing point is there, this crossing point is on the line first and this line second. So if you solve the equations for these two lines, you will get easily the coordinates. Else as and how we are plotting this particular graph on a graph paper, easily you can get the coordinates. And the next point is here, so that is a point D. So this D point, obviously the value of y is 5. If you put that value in the equation of this line, you will get the value for x, and it is 0. Okay, so it is on the vertical line of y, so x0 y5. Now the next step that has been seen while we were seeing the steps to solve the linear programming problem by graphical method, the next step was to put these particular coordinates individually in this particular objective function. These coordinates are nothing but the values of x and y. For example, at the corner point A, value of x is 0, value of y is 0. Here value of x is 6, value of y is 0. Just we'll have to put that value and we'll have to calculate the value of z. So once when I will put x 0, y 0, value of z is going to be 0. When I will put x equal to 6, y equal to 0, so 10 into 60 is going to be 60. Third coordinate is 6 comma 2, so x equal to 6, y equal to 2, so 10 into 6 60 plus 8 into 2 16, so it is going to be 76. And when I will put the 0 and 5, x equal to 0, that means 10x will be 0, and 8y means 8 into 5, it is going to be 40. Okay, so for these four coordinates we are going to get the four different values of z. Now out of this we have been asked to calculate the maximum value of z. So out of these four values of z, the maximum is z equal to 76, and this is going to be the answer. So maximum value of z is 76 when x equal to 6 and y equal to 2. So that means x we have considered for number of chocolate flavored ice cream boxes, and y we have considered for number of mango flavored ice cream boxes. So simply we can say chocolate flavored ice cream boxes are going to be 6 and mango flavored ice cream boxes are going to be the 2, and that is going to be the final solution. Okay, so maximum profit is rupees 76 when company will produce 6 number of boxes of chocolate ice cream and y number of boxes of mango ice cream. This is how we will get the solution for this linear programming problem by using the graphical method. Now let's see some more examples, so we will get the exact clarity. Okay, now one more example is there. Now we will directly take the mathematical formulation of the linear programming problem, because already we know the process how to formulate the problem by from the data we are having. Okay, so simple problem is there: minimization of z equal to 2x plus 3y subjected to x plus y less than 30, y greater than equal to 3, x less than equal to 20, y less than equal to 12, and x minus y greater than equal to 0. So here we have taken such a problem that all the types of constraints we have considered here. It is a lesser than type, it is a greater than type, it is x minus y type also, because this is going to be the different equation. Okay, and obviously last, this is called as a non-negativity constraint. Non-negativity constraint. Okay, let's see the solution. Okay, so the first step, once we'll get the mathematical problem, but the first step is to consider one by one each constraint, equate the variables with 0 and get the coordinates for x and y. Okay, where there is a no x, get the coordinate for y, where there is a no y, get the coordinate for x. Okay, so the first constant is x plus y less than equal to 30. When we will convert it into equation, it will become x plus y equal to 30. Put x equal to 0, you will get y equal to 30. Put y equal to 0, you will get x equal to 30. Okay, so coordinates are x30, y30. Second is y greater than equal to 3. When you will convert it into equation, it will simply become y equal to 3. Third is x less than equal to 20. When you will convert it into the equation, it will simply becomes x equal to 20. Fourth constraint is y less than equal to 12. When it will be converted into the equation, it will simply become y equal to 12. And the fifth last constant is x minus y greater than equal to 0. When it will be converted into the equation, that means x minus y equal to 0. So ultimately it will become x equal to y. So whatever will be the value of x, same is going to be the value of y. Okay. So the first coordinates are x30, y30. Second is y equal to 3. Third is x equal to 20. Fourth is y equal to 12. Okay, so fifth, intentionally I have once again written this particular constraint x minus y greater than equal to 0. We'll let you know that why it is required here, and its coordinates are x equal to y. That means whatever value of x, same is going to be y. Okay, so now we are having the all the coordinates. So now we'll go for plotting of the particular graph. Okay, so we'll have the x axis, we'll have the y-axis, and as I have stated earlier, just see the values of x and y, and accordingly you will have to plot the coordinates. So maximum value of x is 30, maximum value of y is 12. Okay, so maximum we need coordinates up to 30, that will satisfy all the numbers. Okay, so 0, 5, 10, 15, 20, 25, 30, 35, 40, and 50. Okay, we have taken in the step of 5. Similarly at y-axis we have been taken up to 50. Okay, so as and when each problem will have the solution in first quadrant only, so it is going to be in first quadrant. Okay, so let's take the first coordinate, x30, y30. x30, y30, so this is going to be the straight line which will represent x30 and y30. So this is for equation number first, and it is actually a lesser than type equation. It was lesser than type equation, so I will consider region below the line, region below the line. Now second, y equal to 3, so y equal to 3 line will be plotted here, because x is 0 here, so y equal to 3, it will be parallel to x-axis. This is the second line, and it is also, it was greater than 3, y was greater than 3. So greater than means above the line, lesser than below the line, greater than above the line. Okay, so third is x equal to 20, so it will be again straight line, and that is parallel to y. This equation was x less than 20, x less than 20, that means towards origin or less than or below the line. So it is a third equation, and this is going to be the region. Okay, so inequality sign will specify the region. Fourth is y equal to 12. It will be again line parallel to the x-axis. This is a fourth equation, and it is again less than type, so region will be below the line, below the line. Okay, now the fifth equation is x equal to y. X equal to y means whatever the value of x, that will be the value of y. So x0 y0, x1 y1, x2 y2, x3 y3. So it is going to be a straight line passing through coordinates. That is the origin. It will be a straight line, so it is going to be fifth. Okay, now here comes why I have taken this particular inequality constraint once again here, x minus 5 greater than equal to 0. Okay, so now if you will put these values here, the value of x and y, if you will try to put the value of x and y, you may understand that this subtraction x minus y must be either equal to 0 or greater than 0. When it is going to be equal to 0, when the value of x and value of y is going to be same, that time it is going to be 0. But when we want it is greater than 0, that means the value of x must be greater than value of y. Then only we will get the positive value and it is going to be greater than 0. So if you will specify, so value of x must be greater than value of y. So if I will take any value in this region, means above the line region, so just if I will take the 20, if I will take the 20, so 20 here I have taken, so here it is a uh, y equal to 20, y equal to 20, and if I will move parallelly to the lower side, x becomes 15, x 15 y 20, so it will be negative answer and that will not satisfy this constraint. So obviously all the point must be in this region, lower region, so that we have considered the lower region, this region. Okay, so according to all these coordinates we have got this particular region. Okay, so here you will understand which region we have got. This is the common region and this is called as a feasible region. This yellow colored region is called as a feasible region, which is going to be the common region for all the lines. You just refer this particular arrows, you will get the common region. Now we are having these boundary points, this one, this one, this one, this one. These are called as a corner points, which will give the required solution. Okay, so our objective function is minimize z equal to 2x plus 3y, corner points and values of z. So first corner point is a. Already I have told you that just solve the equation for these two lines, where there is a crossing point, you will get the coordinates. Okay, otherwise whenever we are plotting this particular lines on a graph, easily we can plot get the coordinates by moving parallel to x and parallel to y axis. Else this we know that this is the line parallel to x axis having the value as y equal to 3. So we know the value of y equal to 3. Just put that value in this equation of line, so it will be clear. So it is going to be 3 by 3 because this point is on the line x equal to y. So once y 3, x is going to be 3. So 3 by 3 or 3 comma 3 is the corner point. Second is the point b. You can go clockwise or you can go anti-clockwise, that will not be a matter. B point. So again here is a one horizontal line which has been plotted at y equal to 12. That means y coordinate we have got 12 and another crossing point is on the line x equal to y. So x12 y12, we'll get the coordinates 12 comma 12. Next point is C on a horizontal line where y is equal to 12. Just we want the value of x. So put the y equal to 12 value on this line equation first, you will get the value of x. It is 18. 18 comma 12. Another is a D. Here is a straight line which is having the value of x as a 20. Put the same value 20 in the equation of this first equation, you will get the value of x. It is 10. So it is 20 comma 10. And last point is E. Here also one is horizontal line having the value of y as 3. One is vertical line having the value of x as 20. So 20 comma 3 is a clear. So mostly the points will get easily. Now the next step, we know that just put these coordinates into this objective function. So x3 y3, when you will put, you will get the value of z as 15. x12 y12, value of z will be 60. x18 y12, value of z will be 72. x20 y10, value of z is 70. x20 y3, value of z is going to be 49. And what has been asked? Calculate the minimum value of z. So what is the minimum value out of this? That is z equal to 15. Z equal to 15 when x is 3, y is 3. So as minimum value is 15 for coordinates at A, that is x equal to 3 and y equal to 3. So this is going to be the final answer. Let's see one more example or one more different type. The problem is minimize z equal to 200x plus 300y subjected to 2x plus 3y greater than equal to 1200. Second is x plus y less than equal to 400. 2x plus 1.5y greater than equal to 900. That is constraint number 3, and x plus x comma y greater than equal to 0. So here also we are having different types of constraints, lesser than also and greater than also. Okay, so the first step that we need to go for is the conversion of this constraint inequality constraints. So we are having these three constants and also of different types, because one is of greater than type, one is of lesser than type, and the function objective function as minimization. Minimize z equal to 200x plus 300y. Okay, so as per the regular practice, we are having a first step as to convert all the constraints into equation, then calculation of coordinates and plotting of the coordinates on a graph. Okay, so simple. Let's convert 2x plus 3y greater than equal to 1200 into equations. So it will be 2x plus 3y equal to 1200. Then once we'll put x equal to 0, calculate y. Then put y equal to 0, calculate x. Okay, so we will get x equal to 600, y equal to 400, because when x will be 0, 1200 by 3 will be 400, so y will be 400. When y will be 0, x will be 1200 by 2, that is a 600. Okay, so first coordinates are 600 and 400. Second is x plus y less than equal to 400. So simple, when you will convert it into equation, simple, x equal to 400, y equal to 400. Third is 2x plus 1.5y greater than equal to 900. Here when we will convert it into equation, once we will put y equal to 0, then x will be equal to 450, and when we will put x equal to 0, then y will be equal to 900 divided by 1.5, that is 600. So coordinates are 450 comma 600. Okay, so these are going to be coordinates for three different types of constraint. Okay, so as a routine practice, we'll have to plot it on a graph. Okay, so let's have a x-axis, let's have a y-axis. Okay, once again the same practice, we are having the maximum value of x as 600, maximum value of y as 600. So we want the coordinates up to at least 600. Okay, so we'll plot in this format: 0, 100, 2, 3, 4, 5 and 600. Similarly, along the y-axis, 0, 100, 200, 300, 400, 500 and 600. Okay, now we are having the non-negativity constraint, that is x comma y greater than equal to 0. So all the values are going to be in a first quadrant. Okay, so it is going to be in a first quadrant. Okay, so let's take the first coordinate, 600 comma 400. So here is a 600, here is a 400. So this is going to be the first line which will connect point 600 and 400 for equation number constraint 1. Okay, so it is greater than, so it will be above the line, or away from the origin, above the line. Okay, so it is a greater than type. Okay, so it will show, these arrows are showing it is above the line. Okay, so let's go for second. This was the first. Second is x 400, y 400. So x 400, y 400, it is less than 400. Less than 400 means below the line. So these are going to be the below the line. Below the line means below, towards the origin for second equation. Third is coordinates are 450 and 600. So here is 450, here is 600. So it is going to be these line connecting the 2 points 450 and 600, and inequality is greater than type means above the line. So this is above the line, this is above the line. Okay, so now if we will think that the first equation is showing above the line, second is showing below the line, third is showing above the line. Now we will have to find out a common region which is called as a feasible region. Okay, we can see here now, here is going to be these are going to be region, because these lines are showing above the line, these are lines are showing below the line, so there is no any common region. So I have written here, as there is no any common region, hence it is not possible to get feasible region, because common region itself is called as the feasible region. So this is called as infeasible solution, because we are going to get the solution from corner points of feasible region, but here feasible region is not available, because it is there is no any common region. No any common region means no any feasible region. No any feasible region means no any coordinate points, and that means solution is infeasible. So this is the one of the type of the linear programming problem. So it can be because of the constraints are of different types, which are not giving a possible required solution. Okay, let's see one more problem. Maximize z equal to 40x plus 60y subjected to 2x plus y greater than equal to 70x plus y greater than equal to 40x plus 3y greater than equal to 90, and non-negativity constant as x plus y, x comma y greater than or equal to 0. Okay, so coordinates. So we'll convert the first constant into equation. Now this is going to be simplest process. Equate it equal to 70, put x equal to 0, y will be 70, put y equal to 0, x will be 70 by 2 35. Second constant, put x plus y equal to 40, so x 40, y 40. Third constant, if you will keep here the equality sign, so x will be 90 when y will be 0, and x when x will be 0, y is going to be 90 by 3, that is a 30. So coordinates are these for three constants. We'll plot the coordinates along the graph. So x-axis, y-axis. Now maximum value of x is 90, maximum value of y is 70. So we want the coordinates within this only, 70 or maximum to 90. So 0, 20, 30, 40, 50, 60, 70, 90, again 10, 20, 30, 40, 60, 70, and 80. So we can have y up to maximum 70. Okay, so so we are having the coordinates as per the values we have got here. Now non-negativity constant is x comma y greater than equal to 0, so all the points are going to be in a first quadrant only. Okay, so now let's plot the equations along the this graph. Okay, so first coordinate is 35 comma 70, x is 35, y is 70. Let's connect the 2 points for the first equation. Constraint is saying that it must be greater than or equal to 70. So greater than symbol means above the line. It will show above the line. So these arrows are showing region is considered above the line. Second constraint is x40, y90, x40 and y90. So sorry, x40 and y40. So it is x40 and y40. This is going to be the second constraint, and it is also greater than, so above the line. Third constraint is x90, y30, x90 and y30. So this will be connected like this, and this is also greater than type. So it will also show the region above the line. So these two arrows are showing region above the lines. Okay, so now in this case all the constraints are showing the region above the line. So obviously this region is going to be like this. So this is going to be the region, that is an open region, so that it is called as unbounded solution. It is called as the unbounded solution, because this is not bounded by any boundary. This side the boundary is there, but this side it is not bounded, and in this case we will not be able to calculate the answer. So it is called as unbounded solution. So this is also one of the special case of the linear programming problem.